The robotic animal revolution is here, and it's so much cooler than any of us could have anticipated. These 10 advanced robot animals you never knew existed are the pinnacle of modern robotics engineering and will undoubtedly help to make the world a better, safer place for all of us. Before we get started, make sure you hit that subscribe button so you can keep up to date with all our latest and most exciting content. Miro. Hailed as the world's first biomimetic aquarium robot fish, Miro is amazingly adorable. It comes in 2 sizes with a huge variety of colors and patterns to choose from. Available in 53cm or 35cm, it's the perfect addition to your home and makes for an incredibly interesting talking point. It makes use of a sensory array with a heart controlling the fish's movements. 2 joints move the fish and help to propel it through the water like a real fish, making it extremely lifelike in appearance. Able to avoid obstacles and turn with the help of its fins, Miro aims to push robotics past its current limits. You can add it into a tank all on its own or use it to keep your actual fish company. It's non-toxic and it won't injure your real-life fish, adding a fresh new element to your aquarium. Bionic ants. If you think ants are cool, but don't want them taking over your home, Festo has the perfect solution for you. Their bionic ants use cooperative behavior techniques to go about their daily tasks based on actual natural ant behavioral models. They use complex algorithms to talk to each other and work cooperatively to achieve a common goal. They operate using clear rules to coordinate their actions, acting as a unit. This model even has the potential to be applied in the factories of the future to help machines manage automated tasks of all types. Laser-sintered components mesh with visible conductor structures to produce a unique-looking robot that's as cool as it is groundbreaking. They incorporate actuator technology to move their legs and trimorphic piezo-ceramic elements to provide fine-tuned control when scurrying around. Bionic Flying Fox. Another awesome Festo creation is the Bionic Flying Fox robot. It's ultra-lightweight and uses intelligent kinematics to provide very special flying characteristics to create a new style of robot. Integrated onboard electronics works seamlessly with an external motion tracking system to help the Flying Fox move semi-autonomously in a user-defined space. Inertial sensors help it fly through the air and keep track of objects around it. This impressive robot has a wingspan of 228 centimeters and a body length of 87 centimeters, weighing in at only 580 grams. It has a specially designed elastic membrane with a large wing area for low area loading. The wings can be controlled individually and the membrane is super thin, with a knitted elastane fabric attached to its frame at roughly 45,000 points. Festo designed their Flying Fox with the utmost care, and it can continue flying even if its fabric sustains damage. Moving cameras allow for exact localization, and a motion tracking system constantly records its position to determine autonomous flight paths, using machine learning to help it determine its next move. Crabster CR200. This massive crab-inspired robot is ridiculously cool looking and uses 6 legs to help it navigate along the sea floor. This underwater robot was designed to be an alternative to propeller-driven autonomous ROVs. It's able to handle strong tidal currents in shallow seas better than its predecessors, allowing it to very literally go where few ROVs have gone before. IEEE Spectrum hopes that the Crabster will play an important part in the future of marine research, as well as search and rescue missions. We suspect that this robot will have no problem doing just that. It's less maneuverable than traditional ROVs, but can put up with stronger currents while remaining on course. The Crabster weighs 600 kilos and is controlled via a remote control station, but is able to be easily transported from A to B. The robot is 2.42 meters long, 2.45 meters wide, and 2 meters tall, able to withstand depths of around 200 meters, moving along the bottom of the ocean with the aid of 30 joints to move its sturdy legs, walking at impressive speeds considering its size. Scorpion. This scorpion-inspired robot is unique in that it has a stinger in its tail, although it's not actually dangerous, which is a relief. It scurries around on 6 legs, and when its eyes are covered by an object, it launches its stinger at its attacker, leaving a red mark to show off its impressive accuracy. The team who built the Scorpion hexapod did so in an attempt to redesign a robotic ant that had a few issues that needed ironing out. Scrapping the idea of an ant-based robot, they upped the ante and decided a predator would suit their purposes to a T. The result is a deadly-looking robot that's also very stylish. It's pre-programmed with a number of moves and auto-responses to certain situations. It can also be controlled remotely via a computer link. A long-range IR sensor and 3 short-range sensors housed in its shell detects obstacles and nearby movement, with a front-facing camera giving operators a clear field of view. Chip. A smart and overwhelmingly lovable robot dog, Chip is the cutest robot on today's list. It's really affectionate and uses advanced sensors coupled with smart accessories to keep it aware of its surroundings. The way you respond to this pup affects how it behaves, learning as it experiences the world around it, keeping each Chip one of a kind. Artificial intelligence algorithms help shape Chip's personality, and each robot puppy loves to play games, especially fetch. Chip is able to identify and follow its owner, along with meeting you at the door every time you return home after being away. When Chip's battery starts to get low, he'll automatically return to his base station to recharge, ready to play or even announce when he's hungry as soon as he's all charged up again. Chip has infrared vision and situational awareness, responding to your gestures without missing a beat. He can move around with exceptional speed and feels your touch with cap-active sensor technology. Plurobot. Built to help us study animal locomotion, Plurobot is modeled after real-world salamanders. It's 100% bio-inspired and utilizes some impressive advances in cineradiography to achieve the pinnacle of biomimicry. This lifelike robot can walk on the ground, swim, and even walk underwater with absolute ease. Its movements are so realistic because the team behind it painstakingly tracked up to 64 points on actual salamanders as they moved, allowing them to reproduce 3D movements of bones in detail. They copied 3 separate gaits and exact movements to make the Plurobot as accurate as possible. Plurobot has 27 degrees of freedom and impressive motor skills, with the team at BioRob hoping that their little robot will one day aid in search and rescue operations on land and in the ocean. Robo-Bees. This swarm of robo-bees is made up of many flying microbots that autonomously move through the air while avoiding obstacles and each other with exact precision. Each of them weighs less than 1/10 of a single gram, and they use artificial muscles to propel themselves along. Some can even transition seamlessly between being airborne to swimming underwater. They can also land on surfaces easily using static electricity to hold themselves in place, even on objects with very little surface area. Each of these robot bees is self-contained and self-directed if they need to be, but they can also coordinate their behavior to fly around in very large groups. The Weiss Institute hopes that they can help with crop pollination one day, as well as taking part in search and rescue or surveillance missions. Each bee can also be adapted to be used for high-resolution weather, climate, and environmental monitoring, making them quite an impressive feat of engineering indeed. Aqua Jelly. Just when we thought Festo couldn't up the ante any further, they managed to seriously outdo themselves with their Aqua Jelly. Able to coordinate autonomous behavior as a collective group, Aqua Jellies are able to easily glide and move through the water in any direction they please. They all have adaptive tentacles that are controlled by an electric drive housed in their body. They use integrated communication and a suite of sensors to provide real-time diagnostics to speak to each other and move as one, even in very small spaces. These robotic jellyfish can be paired with a smartphone to relay information back to an operator, allowing them to monitor each individual jellyfish in real time. They relay their temperature, power consumption, position, and direction back to a connected device, even being able to pinpoint their exact depth or strength of the current around them. Eloom. Eloom is pretty much a robotic self-propelled arm with a slender and flexible body. It can travel very long distances with minimal effort, and each Eloom is built to live permanently underwater without needing to surface at all. They can operate even in very rough weather and are used to inspect, maintain, and repair underwater vessels and installations. They have continuous IMR capabilities by connecting to a docking station located on the seabed. A robotic arm is attached to each, and they are completely modular, allowing for a range of activities. Their slender frames let them access hard-to-reach areas using a series of joints, thrusters, and different payload modules to tackle pretty much any task. Sensors and tools can be mounted anywhere along their body. These include thruster modules, sensors, communication modules,